Hi. Good afternoon. How are you?
I'm fine. How are you?
Good, good.
Okay.
My name is your interview today on behalf of.
Okay.
So before we get into the technical questions and all, I would first want to understand from you the kind of projects you have worked on so far. If you could take me maybe through two, three of your projects, talk
Okay.
about your roles and responsibilities on them, yeah, and the kind of challenges you faced and how you fixed them, yeah. So just give me a brief overview on them.
Okay. So, total of 8 plus of IT experience, and like I have been working under the domains like the supply chain management, trade finance, and banking. So currently, I'm associated with the Java development analyst. For around 5.5 years, I've been associated with the company. So, coming on to the current application, the name of the application is Trade Payable Services, which is actually a payments application taking care of the payments of the Mitsubishi suppliers globally. So it works on the discounting model payment cycle of 30, 60, and 90 days, wherein like we are doing a prepayment on behalf of the buyer to the supplier. And so the basic idea is the suppliers are sending us the invoice files in the flat file format, and our system picks up the files and does terms application, discount calculation, and mapping to a funding entity that is responsible for paying that supplier, and ultimately generates a schedule to pay file, that is an STP file, what we call, and that is sent to a integration unit known as treasury, which actually releases the payments on behalf of. So this is the overall idea of the application, and it comprises of two parts. One is like a batch application built using Spring Batch framework, which does not have a graphical user interface. So it consists of multiple Spring Batch jobs, which are scheduled at a regular interval of time, that they can be like a weekly job, daily job, or a monthly job. So this configuration is done through an application known as Autosys, which provides us with the capability of starting the job, resetting the job, killing the job. In case the job aborts, we have the capability of making the changes and then resetting it from the point where the job aborted. So yeah, so this is one module that contains the batch component. The other is the which contains the graphical user interface. So we call it as the TPS web app, where like it gives the supplier the freedom of registering himself and logging to the system to check upon the status of the invoices. That is based upon the payment initialization date, invoice date, release date, and invoice number. Of various filtering mechanisms are available in the application. So overall the technologies what we are using core Java capabilities, specifically Java 8, Spring framework. In the Spring framework, we utilize Spring MVC, Spring Batch, and Spring Boot, and we are using Spring Cloud for the microservices development, and Hibernate as the ORM framework, and yeah, and like Bitbucket as the code repository, Jenkins for the CI/CD tool, and and like Vera code for code scanning purposes. Yeah, and the database is Oracle. So these are the technologies which we are using currently in the application.
Interesting.
Yeah.
Yeah. So moving on, I have few theoretical kind of questions and a couple of programming questions.
Okay.
Could you tell me what are the different ways to manage transactions in microservices architecture?
Okay. So in a microservices architecture, transaction can be managed through different design patterns. Like one can be like a Saga's design pattern, wherein we can have a common messaging queue that communicate to which the microservices are sending in the messages, and these messages are being consumed by other microservices, which in turn can provide the responses to the messaging queue, and based upon the response, like we can have our own transaction logic. For example, suppose we have a microservice responsible for ordering of the product in the application, and other microservice that is like the payment service, which actually does the payment for the ordered items. So in a distributed transaction environment, there has to be a way of communicating between the order microservice and the payments microservice, so that can be utilized with the help of a messaging queue, which can be implemented through Kafka. So yeah, so suppose like a customer is doing placing an order. So before actually committing the order to the order table, we need to have a confirmation from the payment microservice whether the payment for that particular order has been successful or not. So the order microservice pushes a message to the common queue, which is in turn read by the payment service, and the payment service will check for the status of the transaction, whether it has been a successful transaction or a invalid transaction. So suppose the transaction is invalid, then the payment service will push back the invalid message, like it can be with the help of a flag variable, to denote the transaction has been invalid. So appropriately the order microservice will roll back the changes to the order table that have been done. So yeah, so in a distributed environment, like we can have transaction management in this way.
Okay. Could you tell me what does the term bounded context mean in relation to microservices?
Bounded context with respect to microservices means like that a particular resource can be accessed within those particular within that particular context. Suppose we have a microservice A deployed on a container. With the bounded context, what it means is like that the objects or the beans will only be available within that particular container.
Mm-hmm.
So
Okay.
yeah.
Would you say that not every bounded context is a microservice?
Uh, Not every bounded context is a microservice.
Mm-hmm. Would you say that?
Yeah, I think so. Not necessarily all the bounded contexts need to be microservice.
Okay. Tell me, what is the concept of stainlessness in REST?
Statelessness.
Yeah, stainlessness in REST.
Uh, so, like in REST, basically we use the HTTP protocols for communicating over the network. So like each request is considered as a new request. It doesn't remember the state of the previous request that has been done to that resource. So I think this is known as taillessness. Like we have protocols like uh, put, post, patch. So if we are sending a request using these protocols, so even if like we are hitting the same resource again and again, like the previous state is not stored by the protocol. So I think that is what is meant by statelessness. It doesn't store the previous context of the request that was made.
Okay. One second.
Mhm.
So tell me what is the need of static and initializer block?
So with the help of static block, we can only initialize the static data members if like a pre-initialization is needed for static data members. So that is done through the static block. And like for initializing the instance members, if we need initialization before the constructor is being invoked or before the main method for the instance members, then we use the instance block. So the order will be like the static block is executed first, followed by the instance block, followed by the constructors.
Okay. Could you tell me what are the best practices to implement equals and hash code method?
So the best practices are like actually we have a contract between the equals and a hash code. So we always need to preserve the contract while doing the implementation. So the contract basically says if two objects are equal using the equals method, then necessarily they will have the same hash code. But if the two objects are having the same hash code, they may or may not be equal using the equals method. So this contract we need to preserve during the implementation of the hash code method and the equals method. So basically, if we are implementing our own hash code method, we need to take care like for all different objects, we generally return a unique hash code so that the comparison can be done based upon the hash code. So if we maintain like a unique hash codes, then we are taking care of the hash code method. And in the equals method, we need to override it in such a way like to maintain the contract, like the object will only be considered equal if like the hash code is same and other implementation which we can do our own. For example, if we want to compare based upon the name, based upon the different data members. So along with that, we need to take care of the hash code as well.
Okay. Okay. Could you tell me the difference between comparator and comparable, and where can they be used and its implementation?
Okay, so comparable and comparator, the main difference is like first difference is like the comparable is under the java.lang package and comparator comes under the java.util package. The second difference is like if we want to maintain the natural ordering of the elements, then we are using the comparable, which contains the compare to method. And if we want to have our customized sorting, for example, if we want to sort based upon different data members of a class, then we use the comparator interface, like which contains the compare method, which accepts two arguments, whereas the compare to accepts one argument of the type object. So yeah, so like the main difference is like we can have different implementations of the comparator, which can be injected like when we are doing a collections dot sort, we invoke the sort method and pass in the list object, followed by which like we can pass different implementations of the comparator. Suppose we have a student class, so if you want to sort based upon the student ID or student marks or student roll number, these different implementations can be injected in the collections.sort method. Whereas like in the comparable, like only one implementation is allowed.
Okay. Could you explain chain of responsibility, facade, decorator, skeleton design patterns with examples?
Uh, so chain of responsibility.
Yeah.
So, like in Java, like we basically follow like the solid principles uh, for uh, for doing the design portion, like which basically contains like the S is for the single responsibility, O is for open for modification but closed for open for extension but closed for modification. and L is the Liskov substitution rule. I is like the uh, I is for interface segregation, and D is for dependency injection. So, like chain of responsibility, basically it means like there has to be independent segregation on the responsibilities in the classes and the interfaces. So, suppose we are designing an application, so we need to have modularity in the design of the classes. So, one class should only be responsible for one functionality. Same is with the respect to the interfaces. An interface should be segregated in such a way like it is only responsible for one functionality. um, and I have not used the facade design pattern.
Okay. One second. Could you tell me what are the differences between string, string buffer, and string builder?
Okay, so like the main difference is like the string is immutable, and string buffer and a string builder provides us with mutable string objects. The other difference is like the other difference between main difference between the string builder and the string buffer and the string builder are like the in the string builder all the methods are synchronized. So if we want to use them in a concurrent environment, then the ultimate choice will be string builder. And uh, and like the for the performance benefit, like the string buffer will be faster in comparison to the string builder, because we have like synchronized methods in string builder, which ultimately lead to loss in the performance. uh, yeah, so like this is the main difference. So if we want immutable objects, then we are using a string, but if we want mutable objects, we can either use string buffer and string builder. And if we want to use in the synchronized context, we are using string builder.
So tell me, we have those additional classes in Java. I mean, why string alone is not enough?
uh, yeah, so because so every time like if we perform any operation on a string object, so suppose we can create a string object as Ashish, and we perform any operation like the trim operation or concatenate operation on the string. So since string is immutable, it will create a new string object. So suppose if we are appending a text,
Give you an access to the code editor where you
mm-hmm.
can put the logic. Are you able to see the black slide on your screen?
Yeah, I'm able to see that.
Yeah, here you go.
Okay. So we have to find the first repeated character in the string.
Yeah, first repeated character. So O is the first repeated character in the string John Doe. So there you go.
Okay.
So take your time, I'm here.
Uh, yeah, so like in we can use the hash map for this. So we have like a hash map of the uh, type character comma integer. So first we need to like convert the string to array. So suppose the input string is so we need to convert the input string to the array. And then iterate for each character in the input array. So while iterating over each character, just to maintain the consistency, we will convert this to lowercase. So while iterating over each character, we need to put the character followed by okay, so we need to check if it contains C hashmap dot get C plus 1. Yeah, I think this will work. So,
Hello.
okay, you can select the language for it. Okay. So, does it? Can we run the application run the class as well?
You won't be able to run it. We will check and get back.
Okay.
Okay, so it's done, right?
Yeah.
Yeah. So moving on to the last question of the Ashish, it's also programming question.
Okay.
You have to write the program. How would you find the closest value to the given number from the given array? I'll give you an array of sorted integers. Okay. You have to find the closest number. Once again, I'm not able to paste it in the chat. Just give me a moment. I'll explain you the question in the meantime. So array is 2, 5, 6, 7, 8, 8, 9. Okay. And target number is 5. When you look in the array and you need to find the closest number to the number 5, output will be 5 because 5 we already have 5 in the array. Next set target number 11. When you see the array to find which is the closest number to the number 11, you will find 9 as the closest number to the number 11. So output will be 9. Next is target number 4. When you see the array to find which is the closest number to the number 4 in the array, you will find 5 as the closest number to 4. So output 5. Uh, okay, so yeah, so
Can
this is
can you tell me the input array once again? What is the input array?
okay. Input array 2 comma 5
Mm-hmm.
comma 6
Comma 6.
comma 7 comma 8
Okay.
comma 8 again
Okay.
comma 9.
Okay. So if the input number is 5, the closest number will be 2, right?
No, if the input number is 5, the closest number will be 5 because we already have 5 in the array. 5 is the closest and the same number in the array, right?
Okay. And okay. So if the input number is 9,
Then 8.
I'm actually not understanding the question clearly. So can you just
So
ping me the statement once again if you can try?
I think it's not happening, but I'll keep trying. So you have the array. So first set, let's take target number 5.
Yeah.
Hmm?
Mm.
When you see the array, you need to find the closest number to the number 5 from the array.
Hmm.
The output will be 5 because we already have 5 in the array.
Okay.
That is the closest and the same number, right? Next set is target number 11. Hmm?
Okay.
When you see the array, which is the closest number to the number 11 in the array? It's 9.
9. Okay.
Correct. So output will be 9. Last set, target number 4.
Mm.
Which is the closest number to the number 4 in the array? It's 5. So output 5.
Okay.
Okay. So yeah, so you have to write a program. How would you find the closest value to the given number from the given array?
Okay. Can you bring up the black screen where I can type in?
Yeah, 1 second. Are you able to see it?
No. Yeah, no. Okay. So we are being given a sorted array.
Yeah, it's a sorted array.
Okay. So when the input number is 4, then the output is 5, right?
Yeah, correct.
Yeah, I think we should work.
Okay, so done?
Yeah.
Okay. So this was the last. My team will get back to you with details for the next steps.
Okay.
It was really nice meeting you. Have a nice day.
Yeah.
Yeah.
Okay. Thank you.